So good afternoon all.
Good afternoon. Good afternoon.
Welcome to a video on combinational circuit design using design thinking approach. Right. So basically we know what is a combinational circuit. The combinational circuit it describes only the output based on the present state inputs. So which means they don't have any memories. Right. Like adders, multiplexers, decoders. So today we are going to see the design of the combinational circuit based on the design thinking approach. So design thinking approach, what does that mean? So it is a human-centered, creative problem-solving skills that has main 5 stages, right? What are all the 5 stages? Empathize, define, ideate, prototype, and test. So let us see how we are going to design the combinational circuit, not just in designing the circuit, but to arrive at the solution for a real world problem solving skills. Okay, so let's carry on for the design thinking approach for the circuit design.
In design thinking, the first step is empathy. Empathy part is nothing but the challenges faced by the users from their perspective. Today's topic is nothing but combination circuit using a digital lock system. However, in these generations, most of in households and office and school areas, they all use mechanical lock systems, which from the user's perspective, they consider it is like it's not secure. It may the key may be lost or it can be broken. So to compete with that, we are coming with a digital lock system. It's nothing but it can be secure and it can be reliable. So while coming to the digital lock system, it cannot be breaked and cannot be the keys have been lost. We have to simply keep the pin number in the memory. So the empathy part describes that the user's challenges is nothing but we have to use the digital lock system for the secure environment.
Second step in design thinking is the define part. So we have to understand what is the user's need. So we have to, for that we have to first define what is the problem statement is. So so the problem statement suggests that we need a clear system that grant access when the right code is needed. So in this we can identify that the input will be a password. So it indicates an password, or in the simplest way it may represent a binary code. So the output may indicate something the access granted the access. So in this way, it can be useful. For example, a signal that unlocks a doors or a light and LED. So for in this, the requirement is what is needed is when the correct password is given, it will be unlocked. For other combination of password, it will be locked. So this helps us to focus on what really needs in this problem, and rather than distracting the unnecessary features.
Third stage of the design thinking is ideate. So ideate is nothing but the how prototype will be made by ideation. So according to Python's empathy and Bethifa's define, there is a possible in 3 ways. First is AND, NOR gate and combinational circuit. So second one is multiplexer and third one is decoder. So how it be works on AND or AND logic or an AND logic. So it will be processed by zeros and one. If 0 in AND gate, it will be in NAND gate, it will be in 1. So that works. That is works. So another one is multiplexer. So it multiplexers works on based on lion triggering. So correct input is given to the corresponding output. So that only it works. And another one is decoder. So decoder it's have one input and multiple outputs. So one input trigger clock signal is given to that system. So output will be linked to that corresponding output. That's it.
So the next part will be the prototyping part. So just like Mayappan said, there are various combinations of solutions we can bring in, but we'll choose the AND and OR gate solution. So for example, to bring in a good solution,
we have to have the password just like Pradeepa told. So for example, we'll take a password as 101 for our log system. So there'll be like three switches which represents each bit. So if you are taking three digit password means we'll be having three switches. So just like I told before, we'll be taking 101 means first switch will be turned on since it's 1, and the second switch will be turned off since it's 0, and the other last switch will be turned on since it's 1. So 101. So altogether will be connected in an AND circuit. So the final output will be 1. Since we are having 0 in the middle, we will be using NOT gate to invert the 0, because we have to get all the inputs as 1 in order to get the whole 1 as output. So we'll be using combining all these gates together, and finally, if all the three inputs matches only, if we are connecting another LED with that will blink. So if we are giving any other different combinations means it will not blink. So this will be a good and reliable and cost efficient prototype for our problems.
So I'm going to talk about the fifth stage, which means the testing part. So testing part is the part which decides whether our product can survive in this industry or not. So coming to testing, our project is a digital lock system. For this lock system, we have 8 inputs. So we keep one of the input as a password. We try other 7 inputs as a password. If the password is wrong, the input will be 0 and the lock will not open. If the password is correct, then the output will be 1, then the lock will be open. So we must check each and every time whether the lock opens or not at the exact password. So we keep on trying. If the output is correct, then we can execute the product. If not, we have to check to the logic gates and the code which we have written previously. So by checking it, we can rectify the problems and we can produce our project after the testing. So that's it.
So we have come to the conclusion that based on design thinking approach, we can able to find not only for designing a circuit for combinational circuit by implementing the basic gate circuit, but this discussion had given us a brief study about how we are approaching design thinking approach to solve the real world problem as you said in the digital lock system. Right? Thank you.
Thank you.